Alrighty, here we go. Now we're going to kind of hop around in the book. And so not every section of your notes is going to have a chapter and a section number title to it. Because part of this was included in your textbook in chapter 5. Some of it's in chapter 7, some's in chapter 8. So in Schoology, I just call it chapter 7 and chapter 8. Here, I'm just going to give it this heading, transformations slash or hyphen translations. So they sound almost like similar words, but mathematically they mean something different. Okay, so at the top of your notes, make sure you look for those words, transformations, translations. Okay, and here's what our learning target is going to be today. Today, here's what you're going to be able to do. You're going to find the coordinates of translations. We're focusing on this specific type of change today. And you're going to be able to describe it to me in words and then graph the images on a coordinate system. Okay. So we're all about translations today. Now, the bigger word though is transformers. So I bet when I say transformer, you're thinking this picture. The movies weren't out yet when my kids were little, but the toys were. And so transform means to change somehow. And these things change from some sort of crazy vehicle to a robot thing to whatever. But the main root of the word means to change in some way, shape, or form. And that's exactly what we're going to talk about today. So you have a note sheet that should say transformations and translations. And let's first of all define what a translation is. Okay, mathematically, not language wise, because language wise, you're kind of changing from one language to another. Mathematically, what this means is this is what we call a slide. Okay, so in other words, what we're doing is we're moving a figure or a shape of some kind. It could be a point, I guess, too, but to move a figure, and I mean like a polygon, a triangle, a rectangle, any kind of quadrilateral or pentagon, something. So we're taking and moving this figure to a new location on the coordinate system, and it's just like sliding it. So really, what you're doing is you're moving it both in a horizontal direction, or it could be just a horizontal direction, okay? Or in a vertical direction, so we go up or down. I guess I should say horizontally, vertically, or both. And when you move it both horizontally and vertically together, then it looks like you're kind of moving at some kind of slant or an angle. And so that's why I like to use the word slide. Mathematically, we use this term translation. So anytime you see translate, that means slide. All right, you have 4 examples on your pre-printed note sheet, and that's what I would like to concentrate on now. Okay, it says graph and connect the following points to make a triangle. Point A is at -2, 5. Okay, so get that graphed and labeled A. Point B is at 0, 1. 0, 1, right there, right above the origin. So that's my B. And C is at 3, and I highlighted this because originally on my sheet it's a typo that says -2, and I want you to make it +2. 3, 2 is right here. There's C. Then go ahead and connect the dots, and you'll see it makes this cutesy handy-dandy triangle. Okay, there we go. Okay, this is our original image. Now, what I'm describing that I want you to do, this weird notation, the T means to transform it. Okay, and here's how to transform it. You're going to add 1 to the x value of every one of these points. And think about this now. The x is your horizontal movement. And so when you add 1, look at your x-axis. When you add 1, you're moving it to the right. So in words, I'm thinking, oh, I'm going to transform this by going to the right 1 unit. That's a number 1. to the right 1 unit. And then for all of my y coordinates here, the 5, the 1, the 2, we're going to subtract 4. Now, the y is my vertical axis, and when you subtract, you're going down. So we're going to go to the right unit, 1 unit, and down 4 units. And this is how we make this translation. This is a specific transformation. I'm going to change colors so it's easy to tell them apart. It says, what are the coordinates of this translation? All right, well, A was negative 2, 5. And my new A is going to be this. Add 1 to the x. That'll become negative 1. Subtract 4 from the y value. 5 minus 4 is 1. So this is my new point A at negative 1, 1. Oops, I guess I did a bad job of labeling that B because there's my new A value. Now, I can't call this A because it's a new A. And so what we do is we put this little like accent mark. It looks almost like an apostrophe. And this denotes that this is our new A. It's been changed. It's been transformed. And here's what the coordinates of my new A are. Now, rather than saying new A, mathematically, whenever you see this notation, we say A prime. So you'll hear me call it this now. A prime is my new transformed A point. Okay, so I'm going to label that A prime. Okay, B was at 0, 1. Now I have to add 1 to the x coordinate. So that'll become positive 1. And subtract 4 from the y coordinate. 1 minus 4 is negative 3. So here's B prime. Okay, it's going to be at positive 1, negative 3. So there's my new B, B prime. Connect those. And finally, C prime, the transformed point for C, started at 3, 2, and now it is going to be at 4, add 1, and minus 4, negative 2. 4, negative 2. And there is C prime. There we go. Now, when you take a look at how the image looks on, excuse me, on the graph, you'll notice that my triangle didn't spin at all. That's called a rotation. It didn't flip at all. That's a reflection. It just was picked up and slid or moved into a new spot on the coordinate system. We shifted 1 unit to the right and down 4, and there it landed. That's why we call this a translation. All right, so there's the first example. I give you the directions algebraically on how to transform each one of those points. You apply the math and graph it. Now, we should talk about pre and post image. You see this on your notes. So if you would, your starting triangle here, this is what we call pre-image. This one, A prime, B prime, C prime, this is called the post image. Aha, so do you see what that means? The prefixes help you out a lot with pre and post. This is the before, or your original point, and this is the after, or the ending figure, and this is after the transformation. This applies to any kind of transformation. Okay, so the before and the after, pre and post. Okay, let's do another one. Graph and connect the following points to make this rectangle. F, G, H, and J. All right, go ahead and pause the video and go ahead and graph this and then start it up again and see what you come up with and see if it matches mine. Here's F, here's G, here's H, and here is J. Makes a nice little rectangle here, okay? That's your pre-image. Now I'm asking you to perform this transformation on it. And the transformation says subtract 3 from the x value, subtract 3 from the y value. Think about what that's telling you to do graphically. If your horizontal movement is subtracting 3, you are going to the left 3 units, and subtracting from the y coordinate means you're going down 3 units. left 3, down 3. Now, some people, rather than doing it algebraically, would rather just count on the grid and say, oh, here is F. I'm going to go to the left 3, down 3, and there's my graph. And then I look at that and say, oh, that's at -7, +2. Okay, so if your brain works that way and you're more visual in that sense, maybe you want to do it that way. You double check it still algebraically. -3, -7, yes, -3, 2. It works. All right, let's get the rest of these cranked out. That was F prime. G prime, 1, 2, 3, 1, 2, 3, is right here at -7. Oops, I guess I'm writing that up here. -7, -4. Does that make sense? -3, -3. My new H prime, is going to be right here. And the coordinates of H prime are going to be at 0, +2. And last but not least, J prime are going to be at 0, -4. Right here, 0, -4. There's J prime. So make sure you label with the proper letters. Make sure you have that prime, that accent sign on there. And there you go. Now, if you want to get really fancy schmancy, then this is kind of a nice way to just simply connect the corresponding coordinates. And now all of a sudden it starts to look three-dimensional. Oh, cool. Cool, cool, cool. All right, let's try a few more situations now that you see how to perform a specific translation. Look at number 3. Oh, no coordinates given here. I'm giving you the pre-image, which is this one, LMN, and the post-image, L prime, M prime, N prime. What happened? Okay, well, if I compare my first L to my L prime, it looks like I went 1, 2, 3, 4, 5, 6. I went 7 units to the right. So describing it, I could say I went to the right 7 units. And then how far vertically did I change? Yikes, I went 1, 2, 3, 4, 5, 6, 7, 8 units down. Well, I guess if I say right 7, down 8 units. Here we go. Okay, algebraically, how do you write that or describe it? I would say X to the right 7 means +7, and all of my Y coordinates means go down 8. Okay, then if I asked you to peel off the coordinates for me, then you would go ahead and do that. Give me all the ordered pairs. In this case, I just wanted you to get used to that. Okay, now the last situation you're going to see would maybe look like this. Look at example number 4 on your notes sheet. This time, I'm giving you R prime, S prime, Q prime. That's where you ended. That's where you ended after this translation. So whatever my original R was, I subtracted 2 to the X coordinate and I landed here. So where did you start? Well, right now my X coordinate's 2. What would you have to have started with in order to subtract 2 and get 2? So in other words, X minus 2 equals 2. That means X had to start out as 4 in this case. So my original for R, my X value is at 4. And then the Y coordinate, from my original, I added 3. So wherever I started, okay, and I landed here, I had gone up 3 and I landed at a level of -1. So Y plus 3 equals this -1. You can just think about this. I must have started down here at a level of -4. So 4, -4. This is where my original R was. Okay, now does that make sense? Think about it. Okay, if I start at my original and I go to the left 2, and up 3, 1, 2, 3, did you land at R prime? Yes. So that matched up. I can put that, lock that one in. How about S? Okay, I have to land here. Okay, and I landed there after I had gone to the left 2 and up 3. So, really, I had to be 2 to the right in a sense, so that when I moved to the left, I landed at 8. And then I had to have been 3 lower, so that when I go up 3, I land at that level. So starting here, I'm saying that's my original S. Check it. If I go to the left 2, up 3, I land at S prime. So this is at 10, -7. All right, last but not least, my original Q. Okay, and now if I draw this in here, oof, this is going to be bad. Sorry. Oh, that's horrible. Gross. Goodness gracious, let me get this in much better shape. Sorry. Get that out of here. Ish kabibble. All right. Connect these guys here. And that's not much better, but hey, there it is. All right, Q. Now this is going to be a little tricky because I'm going to fall off the grid. I have to go basically to the right 2 and down 3 for my original, because when I transform Q by subtracting 2 to the, going 2 to the left and up 3, this is where I have to land. So 2 to the left and up 3. Yes, my original Q is going to be down here at the point 1. And I think it'll be -12. And let's try it. If I put in a 1 and subtract 2, I get -1. And that's this point. Yes, -1. And then if I add 3 to -12, I get -9. Yep, that's right where that point was. Here's what the pre-image looked like. And I had to work backwards there. Okay. So pre-image, post-image. You now can look at things. If I describe the translation to you, you should be able to give me the coordinates, describe it in words, and find the pre and post images of those objects. All right, your assignment is the worksheet, and there are 12 problems on there, and you're dealing with translations only. So we're just sliding the image to a new location on the screen. Good luck, and as always, may the force be with you.